NASA just launched its Mars rover Perseverance, perched atop an Atlas V rocket, to lead one of the most ambitious and sophisticated Mars missions in history.
As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
But NASA wasn't alone. In the past 2 weeks, space agencies from China and the United Arab Emirates also launched missions to Mars. These spacecraft will travel over 400 million kilometers before all reaching their destination around February 2021. But in the past 13 years, only 7 rockets sent missions to the Red Planet. So why are so many attempts to reach Mars all happening right now? Space agencies see the Red Planet as a key to answering one of life's biggest questions. Are we alone?
The chemical signatures, the presence of past water, the sedimentation, everything about that planet is telling us, come and look for life here.
With cheaper, easier access to rockets and spacecraft technologies, and as more countries develop their technological prowess, deep space missions are increasing in numbers. Not to mention, getting to Mars is kind of a flex.
Becoming part of this new space race, as it were, is to show that you can launch really ambitious missions. That gives you all the pieces you need to do much simpler things, like put a bunch of satellites in low Earth orbit. If you can get to Mars, you can kind of do anything.
But why are they all going to Mars now? Well, it comes down to planet alignment, payloads, and orbital constraints. Spacecraft are heavy, but need to travel fast. Very, very fast. And they take a lot of effort to just get off the ground. So it's important to maximize efficiency and reduce weight or payload where you can. Faster, shorter trajectories or flight paths that use minimum fuel are critical for deep space exploration. You can send up heavier flights for lower costs. But Mars and Earth orbit the Sun at different distances and speeds, so they aren't always aligned. At the farthest point of their orbits, Mars and Earth are 401 million kilometers away from each other. And if you try to go then, you're going to spend a long time traveling through space. But at their closest, the two planets can be less than 60 million kilometers apart.
Every 2 years, the planets in their orbits kind of get really close together, and that shortens the distance dramatically by 100 million miles or more to getting to the Red Planet.
And that's where we're at in this current launch window, from mid-July to mid-August.
Waiting for that planetary alignment gives you a huge advantage in terms of speed, allows you to send bigger spacecraft that can do more.
Thanks to the planet's different orbits, this window to launch lasts for about a month, and it only comes around every 26 months. So if NASA hadn't launched Perseverance by August 15th, it would have had to wait until 2022 to try again. But being close is only part of the launch strategy. When you send a spacecraft from Earth, it doesn't just go straight to Mars.
You launch your spacecraft, you get it sort of parked around the Earth, and it's circling the Earth at thousands of miles an hour, and then at just the right moment, you fire the spacecraft engines so that it gets on this path to Mars and just sort of coasts the rest of the time.
That path is known as the Hohmann transfer orbit. You can see that here, an elliptical path that fluidly connects Earth's orbit around the Sun to other planets' orbits. In this case, the planet in question is Mars.
Once you fire your engines, you're sort of like coasting down this river toward Mars because the gravitational pull of the planets and the velocity of your spacecraft is just going to like pull you right toward Mars.
The spacecraft will then meet Mars at the intersection of their orbits about 7 months down the line. So timing is key. You can think of this like a quarterback throwing a football to the receiver. You're throwing the ball to where the receiver will be, not where the receiver is currently running. If the timing is wrong by even an hour and the spacecraft lacks enough fuel to correct the mistake, then the spacecraft might miss Mars altogether and carry on in the Hohmann orbit alone. But if the timing is right, you get to Mars. Depending on the mission, you might slip into Mars' orbit before attempting to land on the surface, or you might go straight to the surface. If you've got a lander aboard that spacecraft, you deploy it, and then begins what many call the 7 minutes of terror. This is the riskiest part of the mission, the 7 minutes between the spacecraft hitting the Martian atmosphere at 19,500 kilometers per hour to softly landing.
So when you're plowing through the atmosphere to slow down the spacecraft, you're generating all the superheated plasma ahead of it. That creates a scramble of electromagnetic radiation, which blocks out your radio signals. You can't talk to your spacecraft, it can't send you data. So you have to wait until it's on the ground before you can really know what's happening.
Communications between Earth and Mars take at the very least 10 minutes round trip, so the landing must be perfectly automated. But this is exactly what NASA is aiming to do with Perseverance, which is skipping orbiting Mars and shooting straight for the surface. If the car-sized, nuclear-powered rover safely lands, it will use its 19 highly specialized cameras to help create groundbreaking 3D imagery.
So it can drill samples out of the soil and stash them on the rover for a future mission to come and collect them and send them back to Earth. These will be the first ever samples of Mars sent to Earth for humanity to look at.
A small helicopter is even hitching a ride on the rover's belly. The copter, called Ingenuity, will be used to test the first ever controlled flight on another planet. The goal of all of this is to learn about Mars' geology and climate, looking for livable environments and evidence of ancient microbial life on Mars. Yeah, you heard that right. Life on Mars. As for the other two missions,
as we know, Perseverance isn't alone on its journey to Mars. One is the United Arab Emirates HOPE probe. This is a satellite that's going to orbit Mars and try to crack some of the climatological mysteries of the red planet. How do the seasons work? How do the gases move around? How do those levels of gases change over time?
And then there's China's more ambitious Tianwen-1 mission.
This is a spacecraft that has an orbiter, a lander, and a rover on it, and it's going to try to do basically all the things you can do on Mars.
If China succeeds, it would become the third country ever to land on the red planet. All three missions are major steps in space exploration and answering some of humanity's biggest questions. But we'll have to wait until February to find out if they all arrive safely. So buckle up and prepare for the ride.